In this example, we are going to look at two different approaches to solving the same thing. So we're going to find the area of the first quadrant bounded by these two curves. So the red is the x to the 2/3, and then the blue is the y equals x minus 4 because it's the linear. And so we're going to integrate it with respect to x, and then we're going to shift and do it with respect to y and kind of show you the difference of sometimes manipulating it a little bit might make it a little easier. So here's the problem with finding it with respect to x. That when we do this, we're going to be finding the area under the curve from 0 to 8. Okay, but the problem with that is when we do this, we're finding the area between the curves. Well, there is no between the curves on that section. So what we could do is we could find the area under the curve from a 0 to 4 on that 2/3 power one, and then find the area between the curves on from 4 to 8. Right, that's one way to do it. Another way to do it is to find the area. Let's do the visual. Let's do this area of this shape from 0 to 8, right, which would be kind of us finding this whole thing. But the problem is we have that piece right there that we don't want to account for. And so we have to subtract out the 4 to 8 section. So we can subtract that out. Okay, so this one doesn't have to be finding the area between the curve. You can independently do it. But if you cut it into this, if that was the look, then we would just be finding the area between the curves. So we're going to take a little bit of a different approach to it because there's always multiple ways to do things. So we're going to go from 0 to 8, find the area of the whole thing. 0 to 8 of x to the 2/3. And then we're going to subtract this area from 4 to 8 of this linear, x minus 4 with respect to x. All right, so we're going to find an area that's going to be too much, and then we're going to subtract a little bit from it. So let's go through the math here. So if we add a power, we're going to take, add 1 to that, so 3/3 makes this a 5/3. We would be dividing by 5/3 or multiply by its reciprocal. And we'll go from 0 to 8 minus, if we do the antiderivative of that, we're going to be adding a power, dividing by that power. So x squared, well, minus x squared over 2 minus 4x from 4 to 8. All right, so let's do our math. So on this one, we're going to plug in 8. So we're going to take 3/5 times 8 to the 5/3 minus 3/5 times 0 to the 5/3. Right, that's the area of the whole thing under the red, but we are extra by this much, so we need to figure out that area. And that area is us going to plug in 8 to that. So we got 8 squared is going to be 64/2 minus 4 times 8 is 32. Minus the 4 plugged in. So 4 squared is 16 divided by 2 is 8. Minus 4 times 4 is 16. Okay, so here we have 8 that's being cube rooted and raised to the 5th power. So cube root of 8 is 2, raised to the 5th is 1632. So 32 times 3/8. I don't know where the 8 came from. 3/5. So 3/5 times 32. So that value, because this is going to go away, is going to represent the area of the whole thing, right? Area of the whole thing. And then I'm going to subtract out whatever this all turns into. So that's 32 minus 32, that goes away. And then we have an 8 minus 16 is a -8 with another negative on here. So that ends up being a +8, but we're subtracting this +8. All right, so if I make this common denominators, this is going to be a 96/5. To make this into fifths, we're going to make it 40/5. And 96 minus 40 is 56 fifths. That is the area under that curve. All right, but here's a different way of looking at it. And if we kind of think back up, we're finding areas under curves. They're really kind of rectangles, right? We're finding all these rectangles that are looking like this, and we're making them infinitely narrow and an infinite amount of them. That's kind of, it's a Riemann sum to an extreme is what we're doing with the math here. But if we were to do this with respect to y, now we would be finding the areas going this way. They would be horizontal rectangles. And so if they were horizontal rectangles, then I would be going from, well, everything when you're doing with respect to y needs to be converted into terms of y. All right, so to take this and turn it into terms of y means to solve for x. So to switch that, we're going to take our x to the 2/3, or y equals x to the 2/3. And if I want to get rid of a 2/3 power to get x by itself, I'm going to raise it to its reciprocal power, which means I'm also raising this to the reciprocal power. Can't see that, that's a 3/2. So we would have y to the 3/2 equals x. And then over here, our y equaling x minus 4, I would add 4. And so y plus 4 would equal x. So those are my two equations. And the blue would be the farthest one out, and I would be subtracting the red from it. So I would do y plus 4. So that equation minus, because that's the farther one out, and I'm subtracting. So that would be like the top, and then that would be the bottom. Subtracting out y to the 3/2. And we would be doing that with respect to y. But everything is with respect to y, which means we're not going from 0 to 8 anymore. We're going from 0 to 4 now. All right, so 0 to 4. So let's see if this is any easier. So if we do this, we're getting a y squared over 2 plus 4y minus, if I add 2 to this, if I add 1, I'm adding 2 over 2, so 5 over 2 multiplied by the reciprocal from 0 to 4. So I got a 16 divided by 2 is 8. Plus 4 times 4 is 16. Minus 2/5 of something. I'm going to take 4 and square root it, which is 2. Raise it to the 5th. So 2, 4, 8, 16, 32. All right, and then that was us plugging in the 4. We're going to subtract the 0 plugged in, which is just 0. So we have 8 plus 16 is 24 minus, was that 64 fifths? So let's put that over 1. So if I make this, so times it by 5, times it by 5, we're looking at 120 fifths minus 64 fifths equals 56 fifths. So it might have made it a little bit easier, but we were actually able to break this up into different pieces that made it a little bit simpler. It's not always going to be the case. There will be situations that doing it in terms of x is actually a nightmare. And it ends up being much simpler doing it in terms of y. Not everyone's going to work like that, but there are going to be some instances where you're like, let me go horizontal versus vertical, because then I have this kind of weird thing that happens when I'm shifting from this section to this section. So 2 different ways to look at it, or just make sure that you kind of follow what are the directions, because the directions might be hinting you into a direction that might be a little bit easier.